Hello, my name is Jeffrey. Today we'll be discussing about vectors. First, we'll begin by trying to calculate the dot product of two vectors. Given vector v1 with element x1, y1 and z1, and vector v2 having element x2, y2 and z2. So to find the dot product of the two vectors is to begin by multiplying x1 with its corresponding element in v2, which is x2, and y2 with the corresponding element in v2, which is y1 with the corresponding element y2, and z1 with the corresponding element z2. So thus it is x1 dot x2 plus y1 dot y2 plus z1 dot z2. Thus, if we have two vectors w and v, it therefore means that we would say 1 times 0 plus 0 times 1 plus 0 times 0. So that is how we arrive by getting 0. How to compute cross product of two vectors. So if we are also given vector v1 and vector v2, then if we want to compute the cross between v1 and v2, is just to do the product in Cartesian coordinate system. That is, we will give it ijk. So if you write ijk and write the vector v1 in the first row, vector v2 in the second, you see vector v1 has s1, y1, z1, and v2 has s2, y2, z2. Then the cross product is just like saying if I imagine that I delete the first row along with the first column having the first row of I and its first column of I. Then I'll be having y1, y2, z1, z2. Then if I do the crossing between y1 and z2 and the crossing between z1 and y2, if I take the difference between the crossing, that is, you see the crossing between y1 and z2, which is y1 times z2, minus z1 times z2. You see the crossing between this and this, if you take the difference, and then I will multiply it by I. So you should also remember that I is assumed to be positive, J is negative, and K is positive, like that in this matrix form. That's Rm plus minus plus minus plus minus. That is the usual representation. So R is positive, this is negative, this is also positive. So the crossing becomes R is equals to y1 z2 minus z1 y2. Then in the second, I delete this row, this column, and the row. Then I'll be having s1 x2, z1 z2. Then I do the crossing between x1 and z2 and z1 and x2. Then if I take their difference, you see it, x1 z2 z1 x2. Then I now take the difference between them. So I multiply the resulting answer by minus j. The third is k. Then if I delete the row and the column, I will have this. And in the same way, if I do the crossing, I multiply k, I arrive by that. So given these elements, if you arrange all these corresponding elements into as it is here, and if you evaluate according as it is represented here, you will arrive with 0, 1, minus 1. So how to compute an angle between two vectors is the third problem. So we have vector v1 and vector v2. The angle between the two vectors is the dot product between the two vectors. divided by the product of the modulus between the two vectors. That is the positive magnitude between the two vectors. So the dot product between vector v1 and vector v2 is 4. If you actually do the dot product between v1 and v2 is 4, which is 1 times 2 plus 1 times 1 plus 1 times 1. That's 2 plus 1 is 4. Then we will now do the magnitude of the vector v1. The magnitude of the vector v1 is the sum of the square of all the elements, and you take the resulting answer, the square root of the resulting answer. The sum of the square of all the elements, and you take the square root of the result. So we arrive with root 3. And v2 also, if we do the same way, we arrive with root 6. So cos theta therefore is equal to 4 divided by root 3 dot root 6. So everything now is root 3 times root 3 is 3, and then we have root 2. So if you rationalize, you will arrive by that. So how to compute a scalar projection? The scalar projection of a vector v1 onto another vector v2 is a number. You see, it's a number, it's not a vector. It's a number pro v1 v2, which is equal to the product between dot product between v1 and v2 divided by the modulus or the positive magnitude. We already know this to be 4, and we already know that because if we project the first vector onto the second vector, then we have to divide by the positive magnitude of the other vector, the second vector. You see, v1 is projected onto v2, so that is why I wrote v2 as a subscript. Then it means we have to divide by its modulus. So that's how this answer like this. How to compute a vector projection? So the projection of a vector v1 onto a vector, actually this is a scalar projection. So the scalar projection of this vector onto this is what we did here. So the vector projection is really different from the scalar. The scalar projection therefore is this, and the vector projection of vector v1 onto a vector v1 is now a vector, but this is a scalar. That's why we arrive with a number. But the vector projection of one vector onto another vector is a vector. But the scalar projection of one vector onto another vector, as the names imply, is a scalar. Then so if we project v1 onto vector v2, it looks as if that vector v1 becomes, let's look at if we project v1 onto v2, then we'll write v1 as a subscript. So is therefore equal to the dot product between the two vectors, v1 divided by v2, or v1 times v2 divided by the modulo of v2, then times the vector v1 divided by its modulus. This is how it is done. First, you do the dot product between the two vectors and the modulus of the second vector, that is the one in which the modulus of the second vector, then times the vector v1 divided by its modulus. So that is, we already know that. So it's like if you look at it critically, it's like we multiply a scalar projection. You see, it is just a scalar projection multiplying vector v1 divided by the modulus of v1. So we already have we already know the scalar projection of vector v1 to vector v2, which is 4 over root 6. Then the modulus of vector v1 we already know from the modulus of a vector, the positive magnitude actually. Hello. Oh. Yeah, so I have to make some corrections. So actually the modulus of vector v1 is is root 2. So, I mean root 3. So since it is root 3, then if you evaluate, it becomes root 18. You know, root 18 is actually 3 root 2. So if we try to rationalize, we arrive by 2 root 2 divided by 3. So if you expand, you arrive with this. So all the vectors, they all have the same value. So thank you very much, and that is it for today.